Okay, we're back with part 2 of inverse functions and logarithms, section 0.5 in AP Calculus. And the first thing we're going to look at is the definition of the logarithmic function. What we're going to do is we're going to look at exponential functions and logarithms, but logarithms are a little more new to you guys. So here we have the definition of base A logarithmic functions. The base A logarithmic function highlighted there is y is equal to log of base A of x. And that is the inverse of the base A exponential function, y is equal to a to the x, where a is greater than 0 and a, of course, is not equal to 1, something we've spoken about before. The domain of the logarithmic function is from 0 to infinity, as is the range of y is equal to a to the x. So notice that switching of the domain and the range. Recall that I've said the domain of the function is equal to the range of the inverse, and then the range of the function is equal to the domain. I forgot to put the -1. The domain of the inverse function. So you can see how they switch. So the range of log base A of x is from negative infinity to infinity, as is the domain of y is equal to a to the x. And you can see the two functions there, where the log is increasing, only increasing, but it's concave down, where a to the x is only increasing, but it's a concave up graph. You notice the other point 1, 0 on the logarithm, 0, 1 on a to the x. So inverse properties for log and a to the x. So if you look at this, what we're doing is we're actually putting them in a composition of functions. 10 to the log of a, so it would be looking at 10 to the u form, right? So we're just saying u is equal to the log base 10 of x. Well, that's going to turn out to be just x, because you're putting the two functions together, 10 to the x and log base 10 of x. And given that they are inverses of one another, then they will produce x as a result of their compositions. And 10, where you have log base 10 of 10 to the x, then that's also going to be x. And then if we have e to the log base e of x, that's going to be x. And if we have log base e of e to the x being the argument, then that's also going to be x. Now, the way we are going to be writing logarithm of base e is just ln of x. And notice I said that just as like that, ln of x. And that would be that expression there instead of log base e of x. So e to the ln of x is x, and ln of e to the x is also x. And it's because of the inverse nature of the two functions, a to the x and ln log base a of x. Oh, also over here, take a second and see if you can answer this, where we have ln of e to the 5th power. And if you guessed 5, or you thought it was 5, it is 5. Okay. So now we're going to use some of those composition of inverse functions and the inverse properties, is what I would call these, to solve for y in an equation where you have ln or a logarithm. So what we do is, if we want to solve an equation with logarithms in it, we often use exponentials or bases. So we're using e as a base here, using this property over here, where if u is equal to v, and as long as u and v, as long as we can take the logarithm of, we can't take the log of a negative number, but as long as I can take the logarithm of them, I can then say ln of u is equal to ln of v. And if I have ln of u is equal to ln of v, then I can always, because that's always going to, as long as it's defined, then I can say that e, that would also be equal then we would say u is equal to v. Okay, so in this case, we only have one logarithm on the left-hand side, so e to the ln of y, then that's going to be y is equal to e to the 2t plus 4 power. Okay, And there's our function, solving for y. We've got our function. Now, I'm not going to make that any kind of a functional notation or talk about inverses. I'm just solving for the y value. Okay, so I used exponentials to solve an ln. And we're going to be using some properties of logarithms. So the product rule, the log of a product is equal to the sum of the logs. The quotient rule, the log of a quotient is equal to the difference of the logs. Remember, these are all the same bases, they say. And that a could be anything. It could be base 10, it could be base e. And then the power rule, the log base a of x to the y, that means we can bring that y out front and rewrite it. Sometimes that allows us to be able to solve for a variable such as y. So pause your video and then rewrite the following expressions using your logarithm rules. Now I'm using ln because I think you're a little less accustomed to it. Okay, so then after you paused your video, then you should have ln of t plus ln of cosine t. So sometimes when we have expressions that are words, we'll put parentheses around it, or not expressions that are words, but expressions that seem like they're a little more complicated because you have more variables or letters, especially when we have trig functions. So we put the parentheses around that. So there we have it. Also to stipulate that cosine t, in this case, must be greater than 0 if you're going to take the ln of cosine t. If you have to expand this one, it's a quotient, so we're going to have ln of a minus ln of sine a. And again, that's going to be the same thing there with sine a, as long as sine a is greater than 0. Okay. All right, so now we're going to work on solving an equation. Okay, if we solve an equation and we're going to use this property where we can bring that t out front. So I take this first step by taking the ln of both sides, and we use ln a lot more than we do log base 10. It's only 2 letters versus 3, but we like it. So I'm going to write this then as t times ln of 1.045, and that's equal to ln of 2. Now ln of 2 is just a number, and so is ln of 1.045. So to get t, all we're going to do is divide both sides of this by ln of 1.045. Okay, and so then we're going to take our calculator out. This is going to cancel over here. These are going to be 1s. So we get t is equal to ln of 2 over ln of 1.045. So I'm going to take a calculator with that, and you have to be careful that you close your ln expression. Generally, if you have ln and you type a 2, you're going to have another parenthesis around that, and then type in your ln, and then make sure you put a closed parenthesis around 1.045. Now, my answer that I get is 15.75. Okay, and there you go. And I'm going to stop the video now and get a third video in here because I think someone is at the front door. All right, thank you. Bye.